Okay, guys. Well, we got most everybody here already. Let me get this. It's going to be a little trickier to work. With only one screen here at the house. I should drag another screen out, make life easier on myself. But well, we'll do what we got to do here. All right, we're going to look at this week's lesson in programming. So shouldn't take a very long time, I don't think. It's not a big lesson this week. And this week's our assignment is just the 5-question quiz. So if you're behind and still haven't turned in a programming assignment from last week or anything, take advantage of this time to do that since we have a small assignment this week. Okay, so looking at our Foundations of Programming assignment for the week, let's go to our grade screen here. You see February 5th is this coming Sunday. So what's due this week is 4.03. The logic of and, or, and not. This is a very useful lesson and something that you use all the time in real life, really. So let's go ahead and go through the lesson together. Just to talk about this logic. So we're using more Boolean logic here today. The logic of many options, like rock, paper, scissors. If you ever played rock, paper, scissors, you know, if you chose rock, you beat scissors, but you lose to paper. You also tie with rock. And this all depends on what set of rules you're following, right? That's life, or well, that's decision making. So it depends on what you play, what your opponent plays, the whole rock, paper, scissors thing. So this lesson, we're going to learn to identify and use compound logic with Boolean expressions. Compound logic, not just simple logic. We're going to make it a little more complicated. And we're going to create and evaluate Boolean expressions for making multiple decisions. So you'll see how this could be useful in writing, like after writing last week's program. You see where this might have helped you do last week's. Let's take a closer look at Boolean logic. You know, the 3 logical operators that can be used to write compound conditions, you know, compares 2 or more things, is and, or, and not. So, you know, we're used to doing that in search engines already. Makes it easy to tell Google or YouTube you want to watch videos that contain cats and sloths, but not goats.
Tried to beat you, but you're so hot that I melted. I fell right through the cracks. Now I'm trying to get back.
Or perhaps you want information on Sasquatch or Bigfoot, but not Yetis. So cats and sloths, but not goats, or evidence of Sasquatch or Bigfoot, not Yeti. So you use that in Google terms sometimes in searching on YouTube stuff. So the words and, or not make a major difference in whether a statement's true or false. So let's look at the Boolean condition and. So if you want pizza with pepperoni and black olives, both conditions on either side of the word must be true. So when you have the and, what comes before the and must be true, and what comes after the and must be true for the overall condition to be true. You're looking for a pizza with pepperoni and black olives, and you find one that has just black olives. That does not meet your test. You were looking for both. All right. There's the or. Or is another one that's very useful. One condition on either side of the word or must be true. So that way, if you did find the pizza that had just black olives, that's fine. I wanted either pepperoni or black olives. Didn't matter. So it could be pepperoni and black olives. But at least one of those has to be true. If at least one of those is true, then the overall condition is considered true because we found one with pepperoni or black olives, either one. And then not. If you use the word not, the condition appearing after the word not must be false for the overall condition to be true. So I want a pizza with pepperoni, but not black olives. So if you find this slice of pizza here and it has pepperonis on it, and it does not have black olives, both of those things have to be true. With pepperoni, but not black olives. Then the state would be true. So when you combine those into a compound condition, each condition is evaluated to be true or false. So let's look down here at just not programming code, but just something that uses these conditions. You want a number that is even and greater than 26, but not greater than 75. All right, so we only want to choose the numbers that fit these conditions: even and greater than 26, but not greater than 75. Somebody give me one of the numbers that would fit that condition.
30.
30, perfect, because that is even number and it's greater than 26, but it's not greater than 75. Perfect, right there. Let's see what else? Anything else in there?
74.
74, perfect. Macy had that in the chat there. Do any of the others meet the qualification? 27 is not even. Nope, I don't believe so. Not even. 18 is even, but it's not greater than 26. 94 is even and greater than 26, but it does not meet this qualification. That has to be not greater than 75. And then 26 is not greater than 26. It's equal to. So submit that. Excellent. Good job. So we understand the logic. Let's look at another real quick. Pick with mushrooms or black olives. So pepperoni does not qualify. Black olives, mushroom. Most of these do, right? Because mushrooms or black olives. It didn't matter if it had other stuff too. We're only checking these two items. It does have mushrooms or black olives. The only one that doesn't is the first one. It just has pepperoni. So I think we understand the logic, because we use that logic in life all the time. Like a word that begins with the letter B or U, and there's an and, ends in ing or ed. So B or U. So surprisingly is out. Demoted is out because they don't start with B or U, but all the rest do. So then we have to see what ends in ing or ed. Understood does not. This one already got knocked out. Bounce does. Starts with a B, ends with an ed. Unicorn starts with a U, but does not end with either of those. Boarding starts with a B, ends with an ing. Unlikely starts with a U, but does not meet the qualifications over here for this or. And demoted. So there's only two of them that start with a B or U and end with ing or ed. Fabulous. A character that's a superhero and part of the Avengers, but is not able to fly. Who knows they're Avengers? Superhero and part of the Avengers, but not able to fly. Who qualifies? See, I see Hulk, Black Widow, Spider-Man, Captain America. All right. Hulk, Black Widow, Spider-Man, Captain America. So Macy threw out there for us. See, Black Widow, certainly a superhero, part of the Avengers, does not fly. Spider-Man, he swings on his webs, but that's not really flying. And he is a superhero, part of the Avengers. Captain America certainly would qualify. And the Hulk, he can jump a long ways, but technically does not fly. Let's see if we're correct. Wonder Woman, Iron Man flies. Wonder Woman's part of DC. She's not one of the Avengers. Batman is not one of the Avengers. Ah, there you go. So we got our super nerd on there. We know what we're doing with all these comic book characters. 4 out of 4. Now let's look at page 3 of this. Let's look at it in a programming context now. So compound expressions. In Python, you've worked with relational operators to compare two values. We said if homework equals done, and that's in quotes. The string operation done. If homework equals done, then print play video games, right? So that's simple. We've done that. We've done an if statement where we just check to see if something's true, and then we have something that happens if it is. But if you had 2 or more conditions that had to be true, this is where I said last week it could have been useful if you wanted to do a more complex if statement. If homework equal done and chores equal complete, print play video games. You got to have your homework done and you got to have your chores done before you can play video games. In this situation, Python would take no action unless both actions are true. If you only had your homework done but hadn't done your chores, it would just skip this loop, right? This is not an if-else loop. It would just, if this is true, print this. In this case, it would not print that if your chores weren't done. Or maybe you had your chores done but didn't finish your homework yet. It would still just skip that. It would not say play video games. We can also use or and not. If homework's done or the chores are done, then you can play video games. But get one of those done before you play any video games. So if either one of those is true, you don't have to have both in this case if it's or. Or in this scenario, if homework equals done, so homework's done, and not chores equal complete. So you got your homework done, but the chores are not complete because we check to see is that true or not. If it's not done, print, thank you for doing your homework. Please finish your chores. All right, no video games yet. I'm going to play some video games today. I was playing some video games yesterday. I had a little Super Mario Kart 8, I think we were playing last night. They've released some new tracks that you can buy. So let's check out some of the programming code they give us for this week. So hashtag logical operators. Define main. So there's our main. So let's look at our main function that's defined here. A equals 50. So we've set the variable A equal to a value of 50. And then we're doing the print statements. Print facts about A. So that's going to print regardless because there's no if before that. That's just a line of code in the main function. So here's what we're checking for the if statements. If A is greater than 10 and A is less than 75, it will print A is between 10 and 75. If A is less than 10 or A is less than 75, print A is less than 10 or greater than 75. So first we check to see if it fits in between those. Then we check to see if it fits outside of those. If either one has to fit and to see if it's in between those. But or if it's either smaller or bigger, then it's not in between those numbers. The last one says if not A equals to 10. So that means that A is not 10, then print A is not equal to 10. And then it ends our main function. So since it says the A of 50, we expect it should print the first print statement, right? A should be between 10 and 75. Let's run the program and see what we actually get here. Facts about A. A is between 10 and 75. And then it goes down and hits this other loop. A is not equal to 10. Right? Because both of those are true. A is not equal to 10 and it's larger than 10 and less than 75. So let's change the value of A. Let's make it 10 now. See, does anything print if it's 10? What do you think? Look at that code. Are we going to see anything if A equals 10? Because I just changed A to 10. So if A equals 10, this is going to be false because A is not greater than 10. So all the way, this and statement says both of these have to be true, so it's not going to print the first one. Is A less than 10? No, A is not less than 10. It's equal to 10. So that's false. How about the other side? Or A is greater than 75? That's false. So both of those are false. So that or statement will be shown as false and will not print this. If A is not equal to 10, well, A is equal to 10. So I don't think anything prints. We run that. It just has facts about A, which is before the if statements. So nothing prints about A because it actually equaled 10. So all three statements end up as false. None of those if statements are true. If we make it 75 on the other end of the spectrum, this and statement still fails because A is not less than 75. It's equal to. A is not greater than 75 and it's not less than 10. So the or statement, neither side of the or statement is true. But this one should print because it's not equal to 10. There it is. A is not equal to 10. So we do get the last one. And of course, if we put 7, 5, there we go. 7,504,535. Run that. A is less than 10 or greater than 75. It's definitely greater than 75. The first one was false because it's not in between 10 and 75. But on the OR statement, A did find a positive, the if statement did find a positive statement about A is greater than 75. So the OR statement is true. And it's not equal to 10. So these last two are true. All right, let's look at the next example. Logical operators, define main. All right, let's go down here. So first thing to do, and I like how they did this. This is very useful because we know that this doesn't always print before you have an input statement. Answer equals input. And here's what they put as their input. Which frozen treat do you like? Select A if it's ice cream or B for popsicles. They put the entire menu right there in their input statement. So it will pop up on the screen. A equals ice cream or B equals popsicles. So, and then I like this true. Now that we have the OR statement, if answer equals A as a lowercase or answer equals A as an uppercase, then that'll be true. So it doesn't matter. They don't have to capitalize the A in this menu selection. And it'll check and say, if it's A, either case of A, then print these things. Else if, there's that elif statement we learned last time, else, which means if that's not true, if it doesn't equal A, then check to see if they typed in B, either a lowercase b or an uppercase b, and then print this. And then main statement. If we run the program, it does pop it up for me, and I'll type A. And look, it draws a little ice cream cone with a cherry on top. If I select B, then it draws a popsicle. Good. Popsicle. All right, run program. Let's do a capital A. Capital A. It says that there it is, the ice cream. Let's run the program and let's choose F. Nothing happens when you choose F. There's nothing in our code to do anything if it's not an A or B. If it's an A, this is true. If not, go down here. If it's a B, this is true. If that's not, then just end the program. There's no loop. There's no exit. There's only check to see if they said A or B. If they didn't say A or B, just keep going on. B, draw the popsicle. It says try typing different values for the input, including upper and lowercase. So we did that. All right, let's look at their last example they have for this week. Define main level equals 22. So here's where we're setting a variable named level to a numerical value of 22. And then we have a variable called hidden character. And we're setting that equal to yes as a string value. And we're setting the message. Originally, the message is going to print nothing, which means if all of this is false, and it says print message down here, we have to tell it what message equals. So if all those false, we need to have this line here to tell it to print just a blank line. And let's see. So it has the level. It's going to print regardless if all of these are false, because we have these if statements. If any of those are true, it's going to change the message. Message. It changes the message. If any of those are true. If all of them are false, it's just going to print your level is and whatever that variable level is equal to, and then print nothing. So let's see what it's checking. Level equals 22, hidden character equals yes. If your level is greater than or equal to 25 and hidden character equals yes, it's going to print this. Congratulations, you unlocked the Sherlock achievement. Now we know that's not going to be true because our level is 22. So if that's false, which it is, we'll go to this statement then. If the level is greater than or equal to 25 and not hidden character equals yes, well, that's not going to be true either because our level is not greater than or equal to 25. But it would print you missed your chance to earn the Sherlock achievement. So if those both are false, now it's going to check this one. Levels less than 25 and hidden character equals yes. Message, you will earn your next achievement when level 25 is complete. So this one should be true because our level is below 25 and our hidden character is equal to yes. If none of those are true, else, okay, so it does have a false through. If this is not true, this is not true, this is not true, then keep looking for the hidden character. This will print. So there, it does do something if all of those are false, because it has an else at the end, not another LF, an else. So if true, do this. If true, do this. If true, do this. If none of those are true, print this. So we would expect, since our level's below 25, hidden character, yes, we will get this one. So let's run our program. Your level's 22. You will earn the next achievement. Level 25 is complete. That's exactly what it has right here. That's what we expected to print. So let's change that now to say, okay, we've made it to level 25. Oh, it's moving the wrong thing. We've made it to level 25. So up here, we'll say our level's up to 25. So this is like some code in the middle of a video game, right? So it's checking your level. You found out, did you find the hidden character? And it's printing this message to the screen. So this is like part of a video game. So our level's 25 now. Run the program. Your level's 25. Congratulations. You unlocked the Sherlock achievement because hidden character was set to yes, and we made it to level 25. If hidden character is not yes, let's say it's no, you missed your chance to earn the Sherlock achievement. We made it to the level 25 that does that, but somehow when we were playing the video game, we did not find the hidden character, so that remained a no. So using if statements and nots, or you can even use ors, but they're not using or in this case because they're looking for two things to be true. And that's how that works. So that's it. That's a big overview, because then we get here and this is the end. Just finish reading the lesson. You can practice this using Python. Click that idle button. You know, you can practice some of that outside of what they did if you want to write your own. You know, practice some of that. And then you complete the quiz, which is the next assignment, which we just have 5 questions, and 2 of them are true false. So 5 questions. All right. That seem easy enough? All right. Fabulous. That's all we have. We will we'll see about Friday. If your grade's below 70%, I'm supposed to have a bowling tournament this week. The conference championship for the bowling team for West that I coach was supposed to be today. It's been postponed to tomorrow. I'm waiting to see if it's going to be tomorrow. It may be postponed to Friday. I'll send an email out and let you know what Friday looks like if you need to come to class, if your grade's below 70. Otherwise, go enjoy the ice. See you guys next time.
Well, you done me and you bet I felt it. I tried to be chill, but you're so hot that I melted. I fell right through the cracks. Now I'm trying to get back. Before the cool done run out, I'll be giving it my bestest, and nothing's gonna stop me but divine intervention. I reckon it's again my turn to win some or learn some, but I won't hesitate no more, no